Okay, in this video, we're going to go over the Chapter 5 material from the midterm review. So here we are, Chapter 5, page 12, and we see that we have a triangle off to the right here, and it says points A, B, and C are midpoints. So these are the points that they're talking about, so draw your attention to these. If they're midpoints, I know a lot of things. I know, for example, that this equals this. I know that this equals this. I know that this equals this. So let's see what they're asking us. It says if AB is 3x plus 8, so if this is 3x plus 8, and DE is 2x plus 24, solve for x, and then solve for each of those line segments. Okay, so what do you know? Very carefully, you know that 2 times the middle, the 3x plus 8, is going to equal the bottom. Make sure that you're putting the 2 in the right spot. Don't set those pieces equal. You know they're not equal. But 2 times the AB will give me the DE. So do this carefully. Distribute nicely. That's 6x plus 16 equals 2x plus 24. And now get your x's on one side. I'm going to subtract 2x here, subtract 2x here. I'm going to make this stuff a little bit smaller so that I have room. So let me do that better. Okay, that's better. Okay, so now I'm going to rewrite the equation with that subtraction taken into account. So now I have 4x plus 16 equals 24. Next, second step, subtract 16 from both sides. Rewrite the equation again. I'm getting 4x equals 8. Divide by 4. Divide by 4. And I'm getting x is 2. So 2 is what I want right there for my x. Now let's plug it in. If AB was 3x plus 8, plugging in the 2 where the x was, I get 6 plus 8 is 14. Now, DE should be 28, but let's make sure that that's true. So if DE was 2 times x plus 24, that's 4 plus 24, and bingo, it's 28. All right, so that all worked. So those are our answers there. Okay, now we're going to use the exact same triangle. So let me take those equations off of it because we don't have that applying down here. The marks I made are still okay. So let's see what they're telling us in this next question that pertains to the same thing about midsegments. Using triangle DFE, so that's what we just used, and knowing that points A, B, and C are midpoints, if DF is 14, so that means that from here to here, that's 14. And FE is 14, so if FE is 14, so that's from here to here, okay, and DE is 12, okay, so that's here. Answer the following questions. Okay, so we've got a lot of questions, so let's look. What's the perimeter of triangle ABC? Interesting question. That's the inside triangle. Well, let's start putting some numbers on here. Look what I can do. If I know that FD is 14, isn't this 7, isn't this 7, and isn't that 7? If you don't know that, you want to go back and look at your notes for Chapter 5. Similarly, if FE is 14, then FB is 7, and BE is 7, and AC is 7. And if the bottom piece, DE, is 12, then this is 6, this is 6, and this is 6. Okay, so now look what I have. I have these 3 numbers that are attributed to the segments inside that small triangle. So, can't I add up 6 plus 7 plus 7 to get the perimeter of the inside triangle. So 7 and 7 is 14, and 6 more makes 20. So that answers 20. Now, we may have helped ourselves out with these other questions. So let's see what we have left to answer. DA, without any symbol on top, is asking you for the length of DA. And I already wrote in that it was 7. FB, the length of FB is also 7. And then DC, that is 6. Okay, so by analyzing the shape, I already had those answers. Okay, now they're asking you about things that are parallel. So line segment FD is parallel to line segment BC. So put that segment size. You're not talking about the length now. You're talking about the segments. And then FE is parallel to AC. And DE, the bottom one, is parallel to the piece right in the middle, which is AB. So there you go. We've got all those questions answered. Okay, let's move on to the next one. Okay, now we're dealing with a perpendicular bisector. So that means that this is 5.2. So this was 5.2. These questions up here were both 5.1, just in case you want to go back and look at things. Okay, JM is the perpendicular bisector of KL. So I have a right angle. Got that. And know that you have a right angle here as well. And I know that KM is going to be equal to ML. Okay. Then it says, so this is perpendicular bisector. What I know about perpendicular bisector is that JK and JL will always be equal to each other. I need that information if I'm going to solve for problem A. So JK is 3x minus 6, and JL is x plus 18. So they want us to solve for x. So set those two segments equal. Okay, I'm going to subtract x. I have 2x minus 6 equals 18. Subtract 6, and I get, I'm going to write it over here, 2x equals 12. Okay, so if I do that, what do I have next? If I subtract 18 minus 6, that's going to give me a 12, as I said. Divide by 2, and I'm getting x is 6. Okay, is that going to work? So if x is 6, will that work? Let's see. Plug in the 6, that's 18 minus the 6, that's 12. So something is not right. So I'm going to have to go back and look at this, because if I put in a 6, it's not going to work. So why don't let's look at this again. Okay, that's okay, minus 6. Oh, do you see what I did wrong? Hopefully you caught it. This should have been a plus. That should have been a plus. That would make this 24. So let me erase this. That makes this 24. I'm going to highlight where I made my error so that you see what happened. Okay, that made this, that, and this 24. And by plugging it in, I figured out what was wrong. So now I do not have this relationship. What do I have instead? I have 2x equals 24, divide by 2, and I get x is 12. Now, I'm going to do the same thing I just did a second ago and plug things in, because if it doesn't work, then I know there's an error, just like I found the error the other time. Okay, so if I plug in 12, I have 3 times 12, which is 36, minus 6 makes this 30. And then if I say 12 plus 18, that makes this 30. That checks. I know that I'm correct. So the correct answer is that x is going to equal 12. Okay, let's go on down to 4. So 4 has to deal with the circumcenter of triangles. That's also a perpendicular bisector issue. So look what's happening here. it says point D is the circumcenter. So remember I've said circumcenter, whenever you think circumcenter, you think perpendicular. Okay, that reminds you of perpendicular bisector of triangle ABC. This means that DE, DF, and DG are perpendicular bisectors. So here's your circumcenter. DF is going to also divide this in half. DG will divide this in half. And DE will divide this side of the triangle in half. Okay, so let's see what else we have. What else do we know? So we know a couple of things. We know that when you take the perpendicular bisectors and put them all into this one triangle and they all meet, certain things are going to happen. Number one in our book for right now is that connecting from the circumcenter to the vertex, right here, that's going to be the same as this, and that's going to be the same as that. Okay, that's the piece we have to know. Okay, so let's highlight those pieces. These pieces are now congruent, and they were forced to be congruent by the actions of those perpendicular bisectors. When they came together, they're in the center of the triangle. From that center to each of the vertices is going to be the same exact distance. And that's why I marked those line segments with 4 hash marks to show that they're equal. So now let's talk about our questions here. So they want to know DC and DB. Okay, so that's 2 of those highlighted areas. What are they going to equal? Well, I know that one's 11.5. So that's what that's going to equal. Okay, next thing. Now they're focusing down here on AG and GC. Well, I know they're equal to each other, but if I know the whole thing from A to C is 21, I can take that and divide it in 2, and I would get 10.5. And that's what those individual lengths are. And then they said FC is 1/2 of what? Well, the whole piece is CB. So FC is 1/2 the length of CB. Okay, so that's all 5/2. So that was circumcenter. When you think circumcenter, I want you to think perpendicular and then perpendicular bisectors. The next one is question 5, and that's going to be 5.3, and those are angle bisectors. And the in-center starts with the letter I, which is a vowel, and so does angle. So I'm going to remember those. That's what you call the point where you have all 3 of those angle bisectors coming together. Okay, so here's our point. Okay, so if they're angle bisectors, then this is what happens. This angle has to equal this. That angle has to equal that. And this angle has to equal that. Okay, what else happens? Well, I'm going to make this a little bit bigger for a second. And I'm going to highlight something. I'm going to highlight this, this, and this. If you drop a straight line from the in-center to the side opposite it, then what happens is a right angle is formed. Other thing that's very, very much worth taking note of is that this equals this equals that. Okay, that's key. So it says if BP is 6, so if this is 6, then PC and PD are also 6. Then remember, these are all coming from angle bisectors. So they tell us if SRQ, so SRQ, that is this big angle here. If that angle is 90, then SRC, which is this angle right here, has to be half of that. So that's going to be, you just make that look better, 45 degrees. Okay? Because that's what angle bisectors do. Okay, so now we have another one. Look at, so question 5, we dealt with all 3 angle bisectors. Now, question 6, I'm looking at only one angle. And it says, looking at the figure to the right, for what value of x does point P lie on the angle bisector? So look, if this is on the angle bisector, then if you draw a line from that letter P, if you drop it right down on each ray of that angle, then 2 things happen. A right angle gets formed in the corner, and this has to equal this. So if you want P to be on the angle bisector, then what's going to happen is x plus 3 is going to have to equal 2x minus 1. Okay, so given that, I'm going to add 1 here, add 1 here. That gives me x plus 4 equals 2x. Subtract x, and 4 is going to equal x, or x equals 4. Why don't we check? Plug in 4, that's going to be a 7. Plug in 4, 4 times 2 is 8 minus 1, that's going to be a 7. So that checks, and we're good. So that answer was 4 for x. Now we're talking about the centroid. The centroid is the next section, so this is 5.4. Centroids happen with medians. Okay, and I said I remembered it by saying, oh, I know what to do. So, oh, I know what to do. What do I do? Well, what is a median? A median comes out of the vertex and divides the side opposite it in half. Okay, so the median coming out of A and divides the side opposite that angle A in half. Median is coming out of B and divides the side opposite it in half. Okay, so I'm going to start filling in things that I know. They told me here if AE is 12, so they gave me that already. Well, if AE is 12, so is EC, and I'm just going to fill that in. Now, they also said that CF is 12. So from C to F is 12. So just think about that for a second. Do you remember the relationships among the parts? So DF is 1/3 of CF. So it's 1/3 of 12. CD is 2/3 of 12. Okay, if you get 1/3 of 12 and you recognize that that is going to be 4, so this is 4, then in order to get to 12, this must be 8. The other thing you should notice is that 2 times DF gives me DC. Okay, so that's good to know. So with that in mind, if I know that AD is 10, that's the longer piece, then DC must be half of that, so that's going to be 5. Okay, so these are the things that I know given the information that was provided in the question. So now let's see if we can answer everything. DC, I said, was 8. AG is that whole length. They gave us the 10. I told you the bottom piece was 5. That makes AG 15. Okay, EC, let's see where that is. EC is right here, and that's 12, because EA is also 12. Okay, AC. So AC is 12 plus 12, or 24. And the last one is DF, which I said was 1/3 of 12, which is 4. So go back over that, because that's a really good activity. for you to review so that you can nail all the centroid or median questions. Okay, now this is 5.5. 5.5 says that any two lengths of a triangle has to add up to less than the sum than the third length. Let me do that better. If they give us these two lengths, 12 and 8, what I know is that the remaining side has to be less than the sum of 12 and 8, but greater than the difference. So what does that mean? It means that that third side has to be between 4 and 20, not inclusive. So I can go from 5 all the way to 19, and any of those sides that I'll pick will make a triangle. If I go less than 5, or if I go to 4, it's not going to be good. If I go to 21, also not working, okay? So I'm dealing with whole numbers here. So that's how you want to set it up. The two numbers they gave us, add them to the right, subtract them to the left, have your inequality sign from reading it from the inside, x is less than 20, reading it from the inside, x is greater than 4. That's how I'm getting these numbers. Okay, and the last thing in 5.5 is triangle inequalities. So you look at this and you say, okay, they want to know what the largest angle is. Well, the largest angle is always opposite the largest side. Largest side is the 7 meters. So the angle across from that is angle R. The smallest side is the 4, and the angle across from that is angle P. Okay, continuing with this reasoning, looking at the next triangle, I see a 9 across from the angle T. Therefore, T must be the largest because 9 is the largest. And the smallest is across from the 5, which is angle S. Last triangle up top here, the largest angle is across from the largest angle is across from side XY. So therefore, it's angle Z. The smallest angle is across from side ZY, which is angle X. Okay, now the next questions here, they ask you for the longest side. They're having you analyze the sides based on the angles. So the longest side is opposite the biggest angle, which would be CD, and I'm going to put the bar on top. The shortest side is opposite the 35 degrees, so that's BC. Longest side for the middle triangle, the biggest angle is 85. Across from that is MO. See what I mean? The shortest side is going to be across from angle O, which is 40, so it's going to be MN. And if it helps you to draw those angles across, that is a good idea. Okay, the longest side is across from angle S, so that's going to be RT. And the shortest side is across from the 15-degree angle at angle R, so it's going to be ST. And that concludes the Chapter 5 material for the midterm. Hope you found this helpful.